Hey guys, I hope that you had time to go ahead and look at or play around with that interactive. So what I want to do is I want to go ahead and kind of review a couple things from last week, and then I want to kind of move on and explain about the reactivity on the periodic table. Okay, so I kind of have made a makeshift whiteboard over here, so I hope that you guys can see this. I know when I kind of move through, there's going to be a glare, so I may have to kind of move some things over. So I know you can't see me. I am still here. But I said I just want to quickly go over and just kind of review about the atomic model. I saw a lot of you guys did your flip grids last week, and some of them were really, really cute. I saw ones with candy. I saw ones with a model, or you guys did marbles. So I saw a lot of cool things last week. But anyhow, just to kind of review about the atomic number, so I'm just going to go back and I'm just going to use carbon for an example. I hope that you guys can see this. I tried to make it large. But with the atomic number is 6. So remember that with your atomic number, that's going to be telling you how many protons that you have and also how many electrons that you have. Okay, so I'm just going to go ahead and put in 6. So I'm going to have my 6 protons, 4, 5, and 6. And then it also is going to talk about so remember that with your atomic number, that is going to be your protons. And also that's going to tell you how many electrons that you have. So remember that with your electrons, that's going to be with your energy shells. So in your first energy shell is that it can only hold 2. Okay, so I'm going to kind of draw in, I'm trying to use a different color here. Okay, so my first energy shell, it can only hold 2 electrons. So there's 2 of them, but remember I need 6. So I'm going to draw my second energy shell, and my second energy shell can hold a total of 8. Okay, so I already have 2, I need 6, so that means I only need 4 more. Okay, so there'd be 1, 2, 3, and 4, and that would be my electrons. Okay. Remember that with your atomic mass, that means for the total amount. And so in order to get your atomic mass, I said a lot of times, remember that's going to be given to you, is that you can find out how many neutrons that you have also by just subtracting your mass from your atomic number, and then that will give you your neutrons. Okay, so that's just a quick review there. So I want to go over, and I just want to talk for the next one about water. We're all familiar with H2O, with that formula. So what that would look like for oxygen, all right, is again, for my atomic number is 8. So that's going to tell me how many protons that I have in the middle, but I'm really not going to kind of worry about that right now because I want to talk about the energy shells. So I also know that it is going to have 8 electrons. So remember in my first energy shell is, and I'm going to kind of do it this way. Okay, remember I'm just going to have 2 in my first energy shell for oxygen. Okay, then for my second energy shell, it can hold a total of 8, but I've already used 2. So that's just going to give me, I would need 6 more. Okay, so here I go. 1, 2, 3, 4, 5, and 6. And there's a reason why I'm kind of putting an electron here and here. Because remember that with H2O, we just have 1 molecule of oxygen, where we have got 2 molecules of hydrogen. So remember that with hydrogen, my atomic number is just 1. So I only am going to have 1 electron. So that's why I'm kind of putting this electron here and here, is to show that's how it bonds. Okay, that's what it's attracted to. Okay, so here is going to be just my first energy shell, and that's where it's going to share that one. Okay, and why I kind of did this one is that this is going to kind of lead into about the reactivity. So with the reactivity, I'm going to go ahead and talk about lithium, and then also with fluorine. And I don't know, I hope you guys can see that. Let me see if I can make that maybe just a little bit larger. And I just wanted to have the number. So let me see if this, I'm going to maybe move it over a little bit. So here's my lithium, and then this is my fluorine. Okay, And I hope that you gathered said in your readings about when you have two letters, the first letter is always capital, the second letter is always going to be lowercase. So that's why lithium is L, capital L, a lowercase I. Fluorine, capital F, lowercase l for fluorine. Okay, so hopefully maybe you can see that better. If not, I hope that maybe you can bring that in a little bit closer on your end. But for lithium, okay, again, my atomic number, okay, I'm going to be focusing on my electrons, is that lithium has got 3 electrons. So my first energy shell, it's going to have how many? Hopefully you said 2. Okay, so there's 1 and 2. All right, so then my next energy shell, even though it can hold 8, I only need 1. Okay, so there's my 1 electron. Okay, that's floating around out there. All right, my next one is fluorine. Okay, my atomic number is 9, so I'm going to have 9 electrons. Again, I'm not worrying about my protons or neutrons right now. So again, I'm going to have my first energy shell can hold 2. All right, my second energy shell can hold up to 8. But let me see, I've already used 2, so I only need 7. All right, so I've got 1, 2, 3, 4, 5, 6, and 7. All right, so if you notice, I remember that my first energy shell can hold 2. My second energy shell can hold 8. All right, so remember this one just has 1 in its second energy shell, and then this one has got 7. So in order for these, right, this one is saying, hey, I'm kind of lonely. I want to join this one. So what it's going to do is that it would actually kind of connect to this one. That would make this energy shell for fluorine then considered to be full. And that's why when you combine these two things is that you're going to have a good reaction, okay, because they are combining together. That's why if you're looking at your periodic table, and if you look to see, I'm going to kind of hold it up close up here. Let me see. Where is lithium? Okay, so lithium is right here. Okay, that is in your group 1. And then as you can see, my fluorine is over here. Okay, so this one, all of these electrons here in the outermost shell is always going to have 1 in its outermost shell, or we call that a valence electron. Over here, you can see that these are always going to have 7 is going to be in their outermost shell. So I said, when you combine any of these with any of these, you're going to get a good reaction. The further down that you go, so lithium would has a little explosion, but if you played around with that interactive, is that if you added some more of these down here, is that you would have a bigger explosion. Okay, so with reactivity from your group 1, okay, is going to react highly with any of these down here. Remember, these are your noble gases, so they would not react, but these would be very reactive. Okay, so I hope that helps to explain about the reactivity on the periodic table. Okay, so I hope you guys have a good day. Hope that explains it. If you have any questions, please let me know. Remember, I have Zoom meetings on Tuesday and Thursdays at 7 and on Wednesdays at 9. So if you have any other questions that you need to see where we can kind of talk it out, please, I would love to see your faces. Miss you guys. Bye.